Everybody, welcome to the session. It's good to see you all. If you have not already done so, I just need you to download this image. This image is going to represent all of the resources necessary to do the work that we're going to do in this session. The line here on the bottom of the screen, curl-L, capital L, kind.kh.work/fetch. And you can do that without the pipe bash and see what the command is. It's just a Docker command that pulls down an image that will then use ARIA2C, which is a Linux download manager, to download a 1.4 gig image and make it available on your underlying machine. If you've not already done that, if you don't already have that image, or if you didn't see any of the communication around making sure that you have already done like Docker pull, Quay.io, kind workshop, kind cache, that's another way to do it. Actually, that might be the way to get you unstuck. Docker pull, Quay.io/kind-workshop/kind-cache. If you could do that, then you'd be good. Yeah. Everybody, welcome. We're going to get started here before too long. If you have not already downloaded the kind cache image, if you saw the tweet and just did a Docker pull of it before you got here, that's great. You don't need to do this again. But if you have not already downloaded that image or made it available on your machine, the quickest way to do so is right here on the last line on the slide. What this will do is download a Linux download manager, and it will make available a flattened image that represents all of the resources necessary to do this workshop in a totally offline way, which is really kind of a fun thing to figure out. So if you've not already done it, please do so. Good point. Muted in the back. Oh, there we are. So if this works for you, then what will happen is it will now be a 1.4 gig image in your temp directory. It'll be called kind-cache.tar.gz. We're going to load that into Docker when we get this all set up. So go ahead and grab that image, and once it's downloaded, it'll be available in your temp directory. So that's where you're looking for it.
Fine. Okay, if anybody's stuck on Windows, look for me and I'll show you the settings.
Not already downloaded the image, please do so. Welcome to the session. I'm glad you're all here. This will be really fun. I'm probably going to get started here. What I'd like to see as we're filing in here, I want to see raise your hand if you have not already started downloading the image. If you have not and you're not planning to, then don't, by all means. But if you have not already started downloading the image, this line at the bottom of the screen gives you instructions on how to do it, right? So what this will do is it's just a Docker command underneath it. If you want to do it without pipe bash, you'll be able to see the output of that command. And what it's doing is it's basically just running a Docker container that will download a 1.4 gig image, which represents all of the resources that we're going to use for this resource or for this lab. As you're walking in, the very last line on this slide, very important one, it's going to be the way you download all of the resources necessary for this entire lab. So if you have not already downloaded it, talk to your neighbors. They have already done it. If you have any questions, raise your hand. We'll get somebody out to you. If you do not already have Docker installed on your laptop, you're probably going to have a rough time. Again, talk to your neighbors. Everybody here, raise your hand if you've installed Docker. That's what I'm talking about. All right. So if you have not already done it, talk to one of those people with their hands raised. Now,
one of the people walking around.
Another quick pro tip. If you have already installed Docker, what we're about to go through is pretty CPU and memory intensive, right? So if you feel comfortable manipulating the settings in your Docker runtime, like if you're running a Mac or a Windows machine, go ahead and give it like some good, I think it's like 8 gig memory minimum. Give it a few CPUs, give it some good stuff, and then go ahead and do that reset so that you can have enough resources necessary to go ahead and build these container images. Because what we're going to do here in this session, we're going to build Kubernetes, the entire Kubernetes code base twice. So I need you to make sure that you have like enough memory to do that. So it's going to be kind of wild. It'll be fun. All right. Welcome, everybody. Guess we probably could get started. Everybody ready to get started? What do you think? Actually, raise your hand if you have already downloaded the image. If this is, that's pretty awesome. Good, good. People who have 2 minutes remaining, 3 minutes remaining. Cool. Right on. Good there. If you have any questions, like I said, just stand up and we'll get somebody out to you. Yep. Can't hear you. Use your mic.
So this command on the screen works on Windows, but you need to do a quick adjustment. Do curl.exe, and then instead of piping to bash, pipe it to cmd, and then that same command line actually works.
This is Patrick Lang, who spends a lot of his time answering questions about Windows and containers. I'm glad he's here. One of my co-presenters.
That one I'm not sure.
We also have Ben Elder, whose idea this was. He works in SIG testing a lot. He's going to come up and do a little intro to Kind. And we have James Munnelly, wild man about town.
Yeah.
He started Cert Manager, started a bunch of other interesting projects. He works for Jetstack. One of the amazing things about this session is that it's coming to you live from 4 people from 4 different companies. Yeah. If that doesn't say community, I don't know what it does. You know what I mean? So it's really great to see that. There are microphones walking around in the audience. If you have questions or if there's anything you'd like to say, just flag somebody down. I'm hard of hearing, so if you're not trying to talk to me with a microphone, I probably won't hear you. So this is the command. If you were to look at kind.kh.work/fetch, this is actually what the command is. And what it's doing is basically just running a download manager to download a much larger file. All right. So as I said, the command's still here at the bottom. So if you're walking in right now, the command is still right there at the bottom of the screen. Please go ahead and run that command. It's curl-l kind.kh.work/fetch pipe bash. I'm a Linux user, so this is the way that I would type it in. If you're a Windows user, Patrick can help you out. There are probably other Windows users next to you. It'd actually probably be helpful if the Windows folks kind of sat together. So if you're a Windows person and you want to sit next to others, I mean, I'm not trying to but you get the point. All right. Because Patrick could help you all so much faster if you were together. So, does that make sense?
Sorry, trying to get people clustered.
I'm saying if you're going to do this on Windows, it might be easier for you to have all of those people kind of clustering together so you can answer their questions kind of quicker.
Okay. But
otherwise, whatever.
Yeah. But why don't we just roll? That video is 1 minute long. It's got all the settings in it.
Yeah.
Can we do that quick? Because that'll help them block people.
True. I didn't make the short link, but it's, he can tell you what the URL is for that. All right. Welcome to the session. All right, let's get started. We got about 90 minutes to get through this. I think we can do it. It'll be really fun to talk through. But so in this session, we're going to do some really interesting stuff, and I'm going to tell you what we're going to be up to. We're going to go through it, and then and then all of you are going to go through it. So by way of introduction, my name is Duffie Cooley. I'm a staff cloud native architect at VMware. I came to VMware as part of the Heptio acquisition. I spend a lot of my time educating and helping and architecting and basically just making sure that people find success with cloud native technologies, whether that means figuring out how to do Kubernetes, or whether that means figure out how to re-platform to Kubernetes, or whether that means how to break up an application into microservices, or when to do that, or why to do that. This is kind of all the stuff I do. So every week I am a part of a video blog series at tgik.io. Go check it out if you have not heard of it. It's a really incredible series in which we talk about wonderful things that are available within this cloud native ecosystem. Pretty fun stuff. We also have Ben Elder, who works on the Kubernetes release team, is actually pretty focused on a lot of the SIG testing stuff. He originally developed Kind to help reduce the amount of time it takes to run end-to-end tests on stuff when presented inside of a PR inside of the Kubernetes codebase. And that has been wildly successful. And he'll come up here in just a bit to talk about what's happening there and what's been done. We have James Munnelly. He's a solutions engineer for Jetstack. James is actually the author of Cert Manager, and then there was another one before that I can't think of the name of, but he's here. We have Patrick Lang from Microsoft. He spends a lot of his time teaching and playing with containers on Windows, working with Kubelet on Windows, doing all of that stuff. He's been working on all this stuff, I think, for actually certainly longer than I have. I think Ben has too. I've been working on Kubernetes for about 3 years now. So, welcome everybody. I see a lot of laptops out. That's good. This is an interactive session. You're going to be doing some hard work on your laptop. We are going to be building the Kubernetes codebase locally on your machine against a commit, and then we're going to show a broken functionality of version 1.16 of Kubernetes. Then we're going to fix that functionality, and then we're going to build it again. We're going to iterate, show the new build. The new build has actually got everything fixed, and we're going to be able to evaluate all of that using local resources on your machine. Why are we doing that? So I came up with the idea of this talk because I found a number of people that I had worked with were nervous about contributing to the Kubernetes codebase. And it's understandable. It's a distributed system, right? There's a lot of moving parts. And when you're actually trying to put together your first pull request against Kubernetes, it may be overwhelming because you're not sure if, in fact, what you're doing is actually going to work, or if it's going to function, or if you've actually correctly written a test, or any of those things. And it's kind of hard to do local testing for this sort of stuff. The awesome thing about Kind is that it kind of changes that game pretty significantly. You can bring up a Kubernetes cluster and configure it in lots of interesting ways right there on your laptop. And because of that, we actually Kind even allows you to build a node image which represents all of the bits built from your local checkout of Kubernetes. And we're going to work through that in this session, right? So the benefit of that is that at the end of the day, you're going to feel comfortable iterating over code and being really confident in pushing that code up into a PR. And the fallout benefits of that are myriad, right? Like, you know, the code quality that we see inside of the Kubernetes code base is going to go up because you're more confident in what you're able to do. You're going to be able to write tests and evaluate those tests against your code base. You're going to have just a much better experience around being able to develop Kubernetes against Kubernetes using kind. And that's what we're going to work through in this session. So really, what I want people to feel comfortable engaging with the community. Like I've definitely had people tell me that they feel like they don't want to contribute because it feels like if they make a mistake or it's like some really obvious mistake that they should have known or noticed. And I'm like, I don't get how you would have noticed that if you're just, you know, developing blindly. Like if you don't have a way of actually like evaluating this stuff locally, I don't know how you would have noticed, right? I have no expectation that you're going to figure that out magically. And so here I am giving you tools so that you can evaluate it locally, so that you can learn, so that you can actually like, you know, play with this stuff locally. And that's going to be the killer feature here. How many people have contributed to Kubernetes before? Awesome. That's great. Bunch of new contributors here. That's awesome. It's going to be a great workflow. So this is our agenda. We're going to get I'm hoping all of you have Docker installed. If you don't, then you're going to kind of be following along, watching me do it or watching somebody who's sitting next to you do it one way or the other. We've started with get the bits, right? So if you're just walking in now, you're going to want to go ahead and make sure you get those bits. You're going to use a curl command to go ahead and download an image that will make sure that we get all the resources necessary. We'll talk about that image here in a second. But we're going to go ahead and get all the bits necessary to run this. It's actually somewhat of a contrived example, and it represents all of the bits necessary to run this lab. All of these pieces actually do apply to kind of like your normal workflow, but they are, you know, encapsulated in a way that we can work through a lab here. So we're going to walk through like some of the differences between what we're doing. We're going to do an overview of the kind project. We're going to do a quick overview of contributing to Kubernetes. Just going to take a look at like how to sign the CLA, where to enter into this whole thing while people are downloading the image. We're going to look at a sample commit, and we're going to build from before the sample commit, and we're going to then build after, and then we're going to verify the functionality of the change. And this is actually going to be pretty fun. So that's our goal. And then finally, we're just going to be super successful. Everybody's going to get it done. It'll be what we're working on. If you don't already have Docker installed, there's some instructions in the deck. If you want to see this deck on your machine, if you go to kind.k8s.work, that's where this deck is hosted. If you want to see it locally, that's where it is. And after this whole session, we're actually going to make this into a tutorial that will be available at kind.k8s.work, so you'll be able to see it there. What we're going to do is going to take some pretty significant CPU and memory resources. So if you're running on a Windows machine or a Mac laptop, you're going to want to make sure that you've configured Docker to give a good amount of memory and a good amount of CPU to that Docker machine. Because if you think about it, what's actually happening there is that you're running a VM that has Docker installed, and you need to give that VM a good amount of resources, because we're about to beat it up pretty bad here, like the next 60 to 70 minutes. If you have any questions about this, or if you need help doing this, or if anything else like that, just raise your hand. We're happy to come out and help you out with this. So once you actually get this downloaded, this is actually kind of talking about what's in there. This is what you're downloading. So the image that we have made available inside of your file system is actually the kind-cache.tar.gz. It should be in your temp directory. Once the download completes, it'll be in your temp directory, /tmp/kind-cache.tar.gz. And what's in here is all of the bits necessary to create Kubernetes. I've created a build environment running Go 113. And that inside of that build environment, I've also checked out Kubernetes in both of those two commits. And as we're working through this process, we'll be able to see how this works. I've also got the base image for Kindest. And this is going to talk about kind of like the architecture of how Kind works. Right? So when you're actually doing a Kind build node image, which is what we're going to do in this workshop, it uses a base image which represents all of the bits that are not Kubernetes. And then we kind of layer on that node image, which is all of the pieces from our build, into that. And then we can create Kubernetes clusters from all of those bits in a variety of really interesting ways. I've got etcd in there, the kubectl, which is basically where we do some of the compilation stuff. core DNS, kindnet, all of the bits necessary to actually do a lot of this work. And Ben can probably talk to you more about like how all these pieces all interact with all of that stuff, but that's what's inside of this really big 1.4 gig image that you've downloaded. Like I said before, this is kind of not real life, right? So like what we're showing you in this session is just to kind of get your head around how it all works and how it all kind of wires up. But I wanted to reduce the number of dependencies for this lab to Docker. I wanted to make it so if you had Docker, you had everything you needed. And so I'm not actually going to have you install kind locally. We're going to do it we're going to do it inside of a container because that way all of it can just work for you. But if you want to do this for real, definitely check out kind.sigs.k8s.io. It has instructions on how to actually interact with that stuff on WSL2, on Mac and Linux. All of this stuff is available. And one of the cool things that happened in the 0.6.0 release is now it's actually available in Brew, and it's also available in Choco. And if you're running Linux, you can just download it from the releases page on the GitHub page. As I said, everything's canned, everything's locally available. What that means is that I've already checked out Kubernetes for you, and I wanted to make this point because I personally found it a little confusing. So when you actually have gone ahead and done the installation of Golang on your local machine, when you're actually checking out the Kubernetes source, you don't actually pull it from GitHub Kubernetes, although you can find it there. You pull it from k8s.io/Kubernetes. And that might be confusing at first, but it's an idiom of Go itself, right? That's a vanity URL. And the thing that actually makes that make sense is if you look inside of the code at the imports, you'll find that inside of that import list, there are a bunch of references to k8s.io/Kubernetes, right? And that way, if we, for some mysterious reason, needed to move off of GitHub or anything else that has to happen, or if we wanted to do like local caching of modules or any of that stuff, it gives us the ability to use that URL for that trick, right? So if you were to download Kubernetes locally on your laptop in real life, you would just do go get -d for download, k8s.io/Kubernetes, and it would download it locally to your Go path. That's how you would do it. You wouldn't check out github.kubernetes. Just wanted to make that point. I found it personally a little confusing at first. So, Mr. Ben, what is Kind? This is actually where we're going to get into like what the Kind project is, why we did it, and some of the architecture stuff. So.
Hi. So Kind is Kubernetes and Docker, and
Mic is on.
Hello? Test. Okay.
Yeah.
Great. So Kind is Kubernetes and Docker. It uses Docker containers to simulate nodes, similar to how you might have a VM. And we needed this for Kubernetes CI and for development so that so that you can locally build and test Kubernetes on your laptop without any online dependencies, without needing cloud credits. You can just do this on your laptop. When I first worked on Kubernetes, I was a Google Summer of Code student, and I was just working on my beat up MacBook, and it was really important to me that I could just do this on my laptop. And back then we had this Vagrant provider, and well, long story short, that's gone. We built this, and we hope that this will let people be able to contribute, test things, develop just with a laptop, no other resources. So this is sort of what it looks like when it's running. You've got Docker on your host and the Kind command line, and then each node is a container in which we run systemd, containerd, kubelet, the entire Kubernetes. And we can run multi-node clusters that have multiple of these node containers working together to simulate a multi-node cluster, so you can test things like rollout. As I said, Kubernetes and Docker, multi-node, HA control plane, very important. There are a lot of local Kubernetes cluster options, but you can, with this one, very easily take a Kubernetes source checkout, modify some things, build it, and run it, which we really needed for the Kubernetes project itself. And we wanted it to be really fast and really stable because Kubernetes has infamously long CI. You can wait like 2 hours to find out if your PR passes checks or not, and we want to drive that down. And with Kind, we've got it well under half an hour, closer to like 20 minutes.
Thank you, Ben. Kind is also an open source project. It's hosted at sig.kh.io. If you want to get involved or if you want to extend Kind to support other functionality, you can definitely put up a pull request there. I'm actually going to pull up that website so you can all see it real quick because I think it's actually pretty good. That's the repository. So this is actually where we do a lot of the documentation of the project also. So some of the other stuff that's changed in 0.60 that I thought was actually really exciting is this local registry functionality, right? So you can spin up a local registry for the cluster that you're using. So if you're doing local development against a container, you want to use it in kind of a Minikube way, right? This is a way of actually spinning up a local registry so you can leverage it that way, which is actually pretty neat. We have functionality for private registries. There's a lot of talk here in the website about the design and how it works. And there's a lot of really great capabilities. You can mount in things like file structures that are like on your local machine into the container. You can disable the built-in CNI and play with things like Calico or Cilium or Canal or Flannel or any of those things. I use this mainly as a learning and teaching tool. So Kind for me is like a hugely valuable thing because I spend a lot of my time educating people on Kubernetes and all of the topics around it. And so with this, you can actually do science. Like you can develop a theory about like what happens when all of your certificates expire, and practice that and see what happens. Right? You can do things like like we're going to do in our session, where we're actually going to build a session. We're going to build a Kubernetes cluster that has some broken functionality or an expressed bug, and then we're going to fix it, and then we're going to make sure that it works. It's just a ton of really great capability. So, if you have the image, go ahead and raise your hand. That is really heartening. It's really good to see. How many people are still downloading? We've got about like 20. How many people are still downloading and it's going to be a really long time? How long is a really long time? 8 minutes? 2 hours? What have you, how does that work? I wonder if you're doing something that is going to like affect your image. But yeah, if you have your phone and you can tether to it, that might be quicker. That'd be kind of wild. Huh? Yeah, I mean, yeah, if you have a USB stick and you want to sneaker net it over, that would be great. That would be super helpful. But it's just that one image that's right there in your temp directory. Those of you who have it, if you have a USB stick and you want to hand it to the other guy, that would also be tremendous. But basically, if you can get that image, we can get started here. But fundamentally, this is the next command we're going to run. And I'm going to go ahead and run that. We're going to take a look here. I'm going to go ahead and clean up my stuff real quick. Remember this command. This is a good one. Ooh, God. Don't do this on purpose. I mean, don't do this on accident. Do it on purpose, but don't do it on accident. But you could because if you're in the process of using local Docker to do all kinds of wild things, and even in our case, like when we're actually doing a lot of building of Kubernetes, it can take up a lot of space, and so this is a way of cleaning it all up. So I have my kind cache.tardz, and if I do ls here, you can see it's 1.4 gig. So this is the image that you're downloading. If you don't already have it, it's probably already still downloading. We're going to go through this. I'm going to continue from here. But if you need help, just raise your hand. Once you get it downloaded, we can make sure that you have the next step, which will be curl-l kind.kh.work/cache. If you look at the output of that command, the reason I did the short link is because it's so much shorter than actually having you type in all of this like from my voice. I want you just to be able to like hear what I'm saying with curl-l kind.kh.work/cache, and then pipe that to bash, and it will run it. So let's go ahead and run that. Oh, I'm sorry. I skipped a step. All right. We're going to do docker load -i temp kind.cache.hard.z, and that will load the image into our container runtime's image store. And that'll take a minute. It's 1.4 gig. We're also decompressing it. It's a tarred, flattened image. So I used Docker export to pull this out of my build environment. So Docker load will take a minute or two while it gets it all uploaded, and it expands it, so untars it. So you're going to see like 4 gig of space taken for all of the images necessary here. So once you actually have the image in temp, it'll be in /temp kind.cache.tar.gz. Your next command will be docker load -I. It should have actually prompted you for that at the bottom of the download, docker load -I, and then pointed at that image, and it will load it into your space. That's your next command. So docker load -I pointed at the image, and if we now do docker images, we can see we have kind-cache locally. And we also have some other stuff that I had downloaded earlier. I guess I didn't wipe it all out. But I have this kind.cache image. And then when I expand that image, I'm going to see a whole bunch of other images come out of it, because effectively I'm using Docker and Docker to load all of those images from the cache image. And if we look back at the slide, we can see what we're expecting to see from the output here. Right, so what's inside of this image is this thing, and it's going to be all of these images. So if you see anything more than that, thank you for all of your Bitcoin mining. I appreciate that. No, I'm kidding. You should only see these images being loaded. So once we actually have docker load -I, and then point to your flattened image, we'll load that into your Docker, and then we'll actually go ahead and expand it. And the way that we'll do that kind.k8s.work, dyslexics untie. All right. Now my image is already loaded, and the first thing it does is it does a Docker PS just to make sure that it's connected to Docker. If you try to run this command by hand and you maybe like skip to the point of actually mounting in the Docker socket, it's not going to work. And then it's going to go ahead and load all of the images necessary. So here we see our build env loading up. We see the pos container, core DNS, a couple of Debian containers, which actually make up kind of the base image for some of the build parts of it. And then the big one is kind cross, if I remember correctly, but I guess we'll see it here in a second. So this is actually the output that you should see on your screen. You've already done docker load, and now you're actually doing curl -l kind.k8s.work/cache, and it will actually expand that image locally, and you'll see all of these images come out. So I'm going to go ahead and up arrow here so we can see the command. These are the 2 commands that you're going to run next, right? So you're going to do, once you actually have the image downloaded, you're going to load it into Docker by doing docker load -I, and then point to the file at /tmp/temp. The file name will be kind.cache or kind-cache.tar.gz. Once you have that image loaded into Docker, then you can actually expand that image, and it will load a bunch of other images into your machine. That will be curl -l kind.k8s.work/cache, and you can pipe that to bash, or you can just copy and paste it, whatever you feel more comfortable with. And that will load all of the images necessary to work through the rest of this lab right there on your machine. When you're done, please raise your hand. I'd love to see it when that's done. Awesome, good. When you're done and somebody next to you is struggling with it, help them. Welcome to the awesome Kubernetes community. Yeah, we're all in it together. There's only 4 of us. There's a lot more of you. If there's anybody struggling with this, please help your neighbor, right? Like, y'all are in this together. We got 90 minutes. I want to see all of us do it. I would love to see like a bunch of us actually achieve this at the end of the session. So once you've actually downloaded the image, and again, if you know what I'm going to do, just to make this easy, I'm going to do this. All right, so these are the 3 commands that you should have run since you've come in the door. Right, the first one will actually help us download the image that you need. The second one will load that image that you've downloaded into Docker. The third one will expand it. I realize that some of you are still downloading. I apologize for that. I hope that it gets done sooner than later. What we talked about earlier was if you have a USB stick with you that you trust, perhaps it might be worth like handing it over to somebody who already has the image. It's the same image for everybody. So if you want to sneaker net it, that might be a little quicker. Download speeds from USB are generally always going to be faster than trying to download it from the internet. Say again? Oh, okay. Yeah. Come on, download faster. No, I'm with you. Mush. I know. Want to hear about what I actually did to make this work? It's kind of wild. So this image, what's happening inside of this image when you look at the output, I'm using a Linux download manager to download that 1.4 gig image. In AWS US West 1, I have 10 25 gigabit interface VMs that are hosting exactly one file. And that is the file that we downloaded. And what ARIA does is I can provide it all of those hosts, and it will basically chunk download across all 10. Right? So the goal was to kind of get the ability to make sure that you could actually download from 10 hosts. You could pull it down bit by bit, in little pieces rather than one big piece. So if it gets interrupted or whatever, we won't get messed up. Right? It'll validate that the chunk it got is the right chunk. Put it all back together at the end of the day in your temp directory. And it seems to be working okay. But sometimes for some, I don't get the 2-hour thing. That blows my mind. So, all right, cool. Raise your hand if you are at this place. Coming along. Help your neighbors if there's anything you can do to help them. Otherwise, we'll just hang out here for a sec while this is happening. After the session, if you're interested, I have a whole bunch of kind stickers. I have a bunch of stickers that actually represent the kind logo. They're going to be here on the stage. So if you want to come get a sticker while you're waiting, feel free to do so. Come on up, get a sticker, or get some stickers. I have a bunch of them. They're tiny. They're like 1 inch by 1 inch, so pretty fun, Stretch your legs. We're going to be at this for a little while. Ah, cool. Hold on, let me. One second. All right. I'm hoping we get everybody to this point. Somebody was asking, so why are we doing the curl thing? And the reason is because I don't expect that anybody's going to stay with me if I were to say, I want you to type docker run --rm --, no, I'm not doing it, right? So instead what I did was I just basically used Jekyll inside of my GitHub repository, and I made a file called cache, and I served it with GitHub docs. And what that's doing is basically giving me a way to express a command in a way that you might be able to pipe it to bash. Makes it very simple. You can copy and paste it. It's actually on an HTTPS secured website. I'm using Let's Encrypt for the encryption. But that's why it curl. That's why it's a remote call, right? I just want you to be able to pull that line and apply it. I don't want you to have to like listen to me rattle on and try and explain what each of these flags does. All right. How many of y'all have all of the things loaded? How many of y'all do not have all of the things loaded? Wow, that's like 10 people. I thought that number would be way higher this hour in this session. I have to say, I'm actually pretty stoked that it's a low number. I noticed that some of you all are sitting together. Maybe that's just a bad luck kind of part of the area. You know, I'm joking. How many of you who have all of the images loaded are running Windows? Just one. Okay, all right, all right. I'll take that. Again, as we mentioned before, if you have a USB stick in your stuff and you want to just grab this image from your neighbor, he probably has it. So if that's a thing that you could do, that might be faster to get you back online. I'm going to move forward here in just a minute. I can't wait unfortunately, I can't wait for everybody who won't get through it. So it may come to a point where you're just going to watch me go through it and just kind of express it that way. But it is what it is. Again, the first command is basically just downloading a fetcher. If you're just walking in, I think we have everybody already here. So, all right. So I'm going to move on here because I have to think about how much time I have left. I think we're doing okay. 3:10. So let's get this thing kicked off. Let's do the fun stuff. So what we're going to do next is we're going to start up one of those images that is in the image repository here. It's the build environment. We're going to kick that off. And the way that we're going to do that, I'm going to show you the command that's going to do it. -L. You're probably all just reading my mind right now. Build env. This is the incredibly long command to actually do that. Right? And what we're going to do is we're going to start it up in a headless mode. We're going to give it a host name so we can easily understand when we're inside the container and when we're not. We're going to mount in the underlying Docker socket. We're doing this because when we're inside of that build environment, we're actually going to leverage that Docker socket to create Docker containers in the form of kind. So that's one of the things we're going to do. We're also mounting in the temp directory. The reason we're doing that is because when we build all of the bits, all of the Kubernetes parts, part of the build process is to rsync all of those parts out of a volume into the temp directory, and then we actually rsync all of those bits back into the kind. Sorry. Can you hear me now? Awesome. All right, so that's why we needed to mount the temp directory in, was just to make sure that the bits, when we are finished compiling them, are available to you when we do the node image build. We're going to walk through that here in just a second. So let's go ahead and get our build environment started up here. So I'm going to do curl -l kind.k8s.work, a domain I'm actually pretty happy to have. Build m bash. Cool, thanks. Yep. And then we do docker ps, docker. Oh, no wonder. Delete cluster. Get clusters. I left something running. Kind. Delete clusters. One moment. This is actually from an earlier demo. I guess I apparently left it running. My bad. All right, so docker ps. We should be able to see our build environment running. It's running as a named container. So I should be able to do docker exec, especially if I can type, build env bash. So let's go back and do that again real quick. The command to get this running is the curl command. Clear. Kind. Bear with me for a second here. I want to make sure it's all on the one screen. Docker stop build env. Here. So the curl command. So there's our command, and then we can do docker exec ti build env. Wow, should have muted before I did that. First. Awkward. Okay. My bad. So these are the commands you're going to run. You're going to go ahead and do your curl command. You're going to go ahead and exec into this. And then once you're in there, this is actually going to where we're going to spend pretty much the rest of the workshop. So I want to get as many people in the room as I can to this place. How many people are there? Oh yeah. How many people are not there? How many people are not there because they're still downloading? All right, okay. Y'all are awesome. Both the ones that are still downloading and the ones that, are actually in the session. So the next thing I'm going to do is I'm going to kind of give you a little overview of what's happening inside of this container. Now you may have noticed that the process that's running is the pause container. And that's because it's a container, right? The container is really just process isolation, so I needed something that would continue to run all the time, so I went ahead and threw the pause binary in there, and that is the actual running command for this container image. And it will just stay running forever. It won't die until you stop it. We are in the Go directory that is expressed by the Go path, right? So inside of here, we have Kubernetes checked out. If I do cd source Kubernetes, k8s.io Kubernetes, I can see that this is, I have a checkout of Kubernetes. Now this is a shallow checkout, so fight the power of doing git fetch or any of that other stuff that you might be thinking, I'm going to do this thing because it's muscle memory. Don't do it. This is all already cached for us. So if I do git log, I can see that I'm on master, and that master is tagged. And if I do git branch, I can see that there are two branches. There's the master branch and the fix branch. We're going to build both of these branches in this session. The first time we're going to build master branch, so let's go ahead and get that started. So what I'm going to do, I'm going to type cd just because, and I'm going to do kind build node dash image dash dash image equals local colon master. You can call this whatever you want. I'm calling it local master. If you stay with me, that'd be probably easier. So once you're inside the build environment, the next command you're going to run, kind build node image dash dash image, we're going to tag it, equals local colon master. And what this is going to do is it's going to build a Docker image using all of the bits from our local checkout, and it's going to put it into your Docker image cache. So the command again, right there, I'm going to hit enter, and it's going to go off the screen really quickly. So I'm probably going to bring up another terminal or something. Let's do that. All right. So now what's going to happen first is we're going to actually build an environment in which to build Kubernetes. And it's going to actually bring up another container, a build image, in which we're actually going to compile all of the bits for Kubernetes, and we're going to compile that against our local checkout. So if we were to look at some of the values for this kube build container, we're mounting in the Go path. We're mounting in that code, and we're going to build that code inside of that container. This is going to take a second, and we're going to see it go through a few different permutations of stuff, right? So one of the first things it's going to do is actually take a look at the other containers that may already be running inside of the system, and if it sees any of them, it's just going to say, I'm not touching this one. I'm going to leave it alone. And that way it can keep track of like what it introduced and what you have. That's why it's going through that process. Then we go ahead and we sync the sources. This is what we were talking about. We're going to rsync the Go path up into the container. And then we're going to go ahead and do a build. Anybody who's built Kubernetes before has probably seen this before, right? So we're going to do a lot of we're going to do a lot of code generation for a lot of the API stuff that's within Kubernetes. And then we're going to start building targets. We're going to build all of the bits necessary from the source that you have locally checked out. So we're going to build kubeadm, kubelet, kubeproxy, kubeAPI server, all of those pieces. And we're actually going to do it in two phases. In the first phase, we're going to build the binary parts. And those binary parts, I mean, like these are the bits that you're actually going to put on the server. You're going to operate these with things like systemd or just from the command line. So like kubekettle is a command line tool, but kubeadm is a command, and kubekettle and kubeadm are both like command line tools, but kubelet is going to be probably operated by systemd. As part of building this, we're going to actually take that base image that we've identified earlier in this process, and we're going to put all of these bits in a new layer on top of that base image. And this is going to give us everything we need to create a Kubernetes cluster from your local Kubernetes checkout. So how I got here, if you're already in the place where you have the build environment started up, then you would be able to exec into it, and then you would be able to run kind build node image, dash image local master. I know that I'm moving forward for some people. If you want to catch up, you can ask your neighbor, ask people around you, or if you raise your hand, we're going to come around and help you out. Remember, if you want to see the slides, all of the steps that I'm talking through are available on the slides. If you go to kind.k8s.work, just hit forward and forward and forward until you find where we are. It will be in the slides. If you haven't already adjusted your memory and CPU settings, it might be too late, but if you have, then awesome. But if you have I can't remember what the default is, but it's something ridiculously low. So especially if you're going to be building code like this. So. just to reiterate what's happening here, I'm actually building all of Kubernetes against a local shallow clone of Kubernetes. And if I were to modify that code, like add some error statements or some debugging statements or whatever, because I want to understand better how things work, I could actually just modify the code directly inside of that directory, and I would be able to build against that. So the reason I want to show you this is actually how you can iterate, right? If you're trying to develop or modify the functionality of a particular component within the Kubernetes database or between the Kubernetes code base, this is exactly what I mean by the power of this particular session, right? You could modify that code, build it, see if it actually builds. If you run into problems, you'll know what to do because it's all right there in your own local output. You don't have to like try and parse what's happening in the end-to-end tests. You can continue to iterate and continue to go through this process. So we're done with the binary bits, and now we're going to go ahead and download those bits out of there. I'll turn off my mic and readjust it. I think it's at the wrong spot. And then we're going to go ahead and build all of the other bits. That's better. And so here in just a second, we're going to see a very different target set, right? But the build command, if you're curious about it, the build command would be something like /hack run.sh make, and then build, and then what. There'd be like a capital what, and then the actual targets for the things that we're watching. So if you look at the output, I can't remember if it's in the output or not, but it is actually what's happening here. We're just using the existing build tools within the Kubernetes codebase to do this build. It is a containerized build, so it's neat because, again, all you need is Docker. You don't need to actually all of the other stuff. So here we're building all of the other bits. We're building the controller manager. We're building the API server. We're building the cloud controller manager, the scheduler, and kube proxy. So if you're developing against any of those things, which is what we're doing in this session, you'd be able to see those outputs. So then we're going to actually show this functionality. So one of the things I wanted to talk about was like what we're actually going to show in this course. So in this, what we're going to do next year is we're going to show a bug that was in 1.16. And what I wanted to express was actually what's neat about this is that the bug is actually in kube proxy when you're running IPVS mode. And the bug is that if you are in kube proxy running IPVS mode and you create a deployment and then expose that deployment with a service, and then you delete the service, the cluster IP associated with that service remains bound. Probably not what you want, right? You said delete the service, the cluster IP should be released. So the neat thing about that is that the fix for that bug is actually the removal of code, which was awesome, right? Removal of code is always a good thing if you can achieve it. And so we're going to actually, we're going to show the fault. We're going to understand that functionality, and then we're going to build again with the new fixed version. We're going to bring up a cluster in IPVS mode and test it and show the different states. So it does actually, yeah. One of the question was like how much of what we've done so far can I reuse if I'm iterating? Right? If I modify the code, am I going to have to go through the entire build process again? And the answer is kind of yes and kind of no. So all that code generation sticks around, but a lot of the actual building of binaries does not stick around. So you're going to rebuild all the binaries, but all the code generation remains inside the cache. And so, but to pop that cache, if this represents a new Git commit, a new hash, then that means that the cache is no longer viable, and it will build a completely new build container. So if you're just modifying code on the fly, you've modified a bunch of files, you mess with some things, and you just do another kind build node image, you're going to leverage that existing cache. If you do a git commit against that, that means that you're going to get a new commit ID, and that means we're going to build a new cache. So that's one of the things one of the questions. So now we got our image. So what I'm going to do next is I'm going to go ahead and flip to the other branch, and I'm going to build it again so that we're not waiting for that to happen. So I'm going to go into source, case, Kubernetes, and I'm going to do git checkout dash, because I'm crazy like that. And what that does is, you probably are aware of like cd dash. It moves you back to another directory. Git checkout dash does that too. I learned that from Chris Nova. I thought that was really cool. So from here, I can go ahead and do that same command that I ran before, kind of build node image. I'm going to give it a different tag, because otherwise that would be weird. So I'm going to go ahead and, again, git checkout into the other branch. I'm going to go down here and add this to the list of commands. Make sure you change the tag. Otherwise, you'll have been creating two containers, both of which are master. It's not going to do what you want. All right? So, how many of y'all are with me? How many of you need like a minute? You got a minute. How many people are like totally still not with me at all? Wow, that's not bad. All right. How many of you have questions? Cool. So, let me get somebody over to you, Ben or Antonio, or if build failed, it might be memory or CPU. Like if you don't have like a good amount of memory or CPU inside of your Docker image, it's going to bite it. Okay, should do it. Yeah. Did you have more than one CPU though? That's surprising. Well, I mean, as you can see, like it's works pretty well. I guess maybe you get bit by the gremlins. Who knows? Oh, I wanted to start that build. So once we have the master tag built, we're going to go ahead and check. We're going to move into source Kubernetes or ks.io Kubernetes. Do git checkout dash. That'll move us to the other branch. You could also do git checkout fix if you want to. That'll pull us into that other branch. And then we're going to go ahead and build another node image with the new functionality, the new change. I want to kick that off because this is actually some of the more time-consuming stuff. Building Kubernetes twice, it's kind of a lot to ask in a session. So if I can get that done, that'll be great. If you have questions, Antonio's coming up to you. Where are Ben and James? Sorry. Oh. Oh, they're back there. Asking some of the questions, or answering some of the questions. Yeah, I just wanted to get the build started. I don't want to wipe out the commands. So as soon as this build is done, we'll definitely look at that. We're also going to look at the commit inside of the Kubernetes code base, like in the PR request and all of that stuff. Kind of look at that feedback. So. Why does it keep the one I don't want it to keep? Hold on. Okay. So this is the pull request that actually is behind this code change, and I wanted to just walk through this real quick. Because it's kind of interesting to understand how to contribute to Kubernetes. And so what happened here is that this engineer determined that there was actually kind of this weird behavior, right? That when they created a Kubernetes deployment at a service and they deleted the service, that the IP address remained around. And they started out by creating a bug that was associated with it. And so the bug that is associated with it, I think is actually in the output. For some reason, I'm not seeing it. But the bug basically highlights the actual problem and describes exactly what behavior they saw. So in kubeproxy and IPVS mode, it describes that whole behavior. And then the engineer went on to actually fix it, which was really great. And so you can see in this pull request exactly what happened throughout the lifecycle of this. And this is just one of many commits. I was actually trying to find like one commit that I could easily identify and show you like all the changes that were happening. And so this is all bundled into one commit, makes it very simple. And here is the change and some of the commentary on the change, right? So this represents removing 19 lines of code. We can see that it's removing 19 lines of code, not adding anything except for better functionality. And we can see some of the questions that happened, or some of the conversation that happened back and forth between Andrew Sykim, who I work with at VMware, and the engineer in question, right? They are already a contributor, which means they've contributed to the code base a number of times. It's unlikely that they actually follow this flow to go through it, but they could have. But yeah, they actually talk about like why this is interesting, why it happened, how it got fixed. This particular issue, if you go to issues.kh.io 80942, that'll be the actual pull request associated with it. So if you're curious more about like how we changed this functionality or what this was about, this is where you'd find it. Now, while we're here and talking about this stuff, I want to go to the Kubernetes Codebase real quick and point out here on the bottom in the README, there is actually information on how to start using it and also on how to start developing it, right? And so this session, we're here talking about how to do the development of it. And if you want to learn more about how to do it, there's actually a lot of information here on how to go through it, and that's constantly updated. And it is also an open source project, so if you see problems with the documentation, feel free to contribute. The community repository holds a bunch of links to different SIGs and a bunch of links to different things that represent special interest groups within Kubernetes that are focused on different areas of the code base. SIG-auth focused on authentication and authorization, those sorts of things. There's also SIGs for different cloud providers, AWS, Azure. We actually have SIGs for things like networking, for SIG node, for SIG CLI. There's a bunch of different special areas that are just really focused on one particular thing. And the benefit of that is it means that the reviewers who are trying to help you get your code into the code base can be really focused on just those things that they've agreed to really focus on. Instead of having to look at the entire code base like Jordan Liggett does all the time, you can actually just look at your own like thing. Just kind of expecting a laugh. That guy's a machine though, like it's amazing. So there's also different work groups that kind of like look into the different functionality. So yeah, this commit basically removes 19 lines of code, very cool stuff. So we're almost done with our second build here, or I am. I hope that most of you are as well. And then we're going to go ahead and build a Kubernetes cluster or two and show off this functionality and show the fix. And then after that, we'll be at the profit stage of our talk. We'll have actually completed it. I hope that that will work for you, and then we can actually answer questions and get everybody else through the session as well. So. Sweet. How many people are done building it the first time? Right on, right on, good number. How many people are done building it the second time? Okay, what are you running? Like, I just started it. You guys must have like supercomputers in there or something. I wasn't slacking. Oh, cool, we got more stickers. We have stickers for Prow. We have stickers for Test Grid. We have stickers for Cert Manager. I'm going to get one of those. We have stickers for Kind. If you want to get up, stretch your legs, feel free. Help your friends. Thank you all so much for sitting through this. I know it's a long session. I really do appreciate the time. I know your time is valuable, and I'm glad you're here. So thank you very much.
Could you elaborate a little bit on what can
Turn it up a little. Questions that just came up was, can you elaborate a little bit more about what kind build node image is doing? And so what happens is when we ship kind, we ship a base image with every release. So right now we're on like 060. And that base image represents everything needed all the way up until all of the Kubernetes parts. It doesn't really include any of the Kubernetes bits, just the underlying base image. So it's a Debian base, and it has all of the bits all the way up until the Kubernetes bits. When you do kind build node image, we're basically firing off a make command against the discovered go path. So if you have your go path environment variable set, we will actually rsync the code found inside of that go path for Kubernetes. So if it were /go/k8s.io/Kubernetes, we'd rsync that entire code base with whatever checkout you have, whatever files are there, into a build image. And then we'll run the make commands, make for each of the binary bits, the kubelet, kubectl, kubeadm, and also the container images. So controller manager, API server, kubeproxy, cloud controller manager. And then we will bundle into that same Docker container all of the bits like etcd and kindnet, which is a CNI developed by Antonio, who's here. He's actually here in this room. He developed it as a very simple CNI to help us do end-to-end testing. It's one of the first ones, and it's actually used, it's one of the first ones that supports kind of IPv6 in a relatively neat way. And it's actually also the one that we use to actually validate IPv6 PRs against Kubernetes, which is pretty neat. So it puts all of that into the Docker image. It just preloads the containerd image cache with all of those bits. And it also puts all of the binaries on disk. And then we actually start all of that up when we do kind cluster create. So when you do kind build node image, we're basically making a brand new Docker image with all of that base stuff and all of the bits that we built when you did kind build node image. And then we tag it with whatever you have actually chosen to tag it with. So in my next command, I'm actually going to create a cluster. But before I do that, I'm going to look at the configuration of the cluster that I'm going to create. So let's take a look at kindconfig.yaml. And this is a file that's here in the Go path, right? So if you take a look at kind.config.yaml right there in /go, you'll find that YAML file. And here is where we're actually kind of expressing some of the power of kind. In our test, what we want to show is kubeproxy in IPVS mode. So for us to do that, we need to enable IPVS mode. And the way that we do it is by providing a kubeadm patch that turns on IPVS mode. And this is actually leveraging kind of the customized capability, and I think to modify kubeadm at instantiation, right? So when you actually do a kind create cluster, and you've specified this type of a patch, then what's going to end up doing is we're going to merge this configuration as part of the default kubeadm configuration for the cluster you're creating. The power of this is that you can actually modify anything that kubeadm can modify using this. So that means that you could do anything. I mean, and I've got a bunch of examples up on my GitHub. So if you go to github.com/MauiLion and you look for the kind repositories, there's a ton of different examples for how to do this stuff. So like one of the examples was somebody wanted to provide a custom configuration to the controller manager, or no, to the scheduler, so that they could modify the default settings of the scheduler, right? And so in that example, I show how to populate the file that all of those settings would happen on your local machine. and then to mount that file into the control plane node, and then to mount that into the controller manager, into the scheduler container, all using kubeadm command, or all using kubeadm conf and the kind configuration to do so. So it's actually a very powerful tool, and you can express lots of interesting ways to create Kubernetes clusters. So all we're doing here in this modification is that we're just modifying, we're patching the kubeadm config in the kubeproxy config model to enable IPVS mode. So let's go ahead and kick off a cluster. Create cluster config. And then the image that I'm going to pass is local master. So I've got a command here that says kind create cluster. I'm going to pass it a config file, which is in the Go directory, right? So it's going to be kind create cluster -- config, kind config.yaml, -- image equals local : master. That's the master build that I had. And then I'm going to let that get started up. And we're going to talk through what's happening here while this is starting up, right? So the first thing we do is we create the Docker container that represents that node, the one control plane node that we're creating. The second thing we do is we munge any of those patches that we saw in that kind config with the kubeadm configuration of the host. And then we actually present that kubeadm config within the node so that we can, when we do kubeadm init, all of that configuration is made available to the instance. The next thing we do is we install a default, we go ahead and fire off kubeadm init. So when it says starting up the control plane, that's like kubeadm init -- config /kind /kubeadm.conf. After that, we go ahead and install the default CNI, and then we install a storage class. So, and this storage class is just using the dynamic local host provisioner. So it's actually any PV that you create is just going to be made available in /temp. So it doesn't do cross-node provisioning yet, but at the same time, you could use it to evaluate other tools for that sort of stuff. Once that configuration is complete, then we will have created our cluster, and from inside of here, inside of the container, if I do docker ps, I can now see the image that started up, right? And the node is called kind control plane. So to backtrack a little bit, once I actually have the second image built, I've looked at the kind config, and then I'm going to create the first cluster, which shows the broken state. And then I'm going to exec into it and show that broken state, right? So first, let's do docker exec ti. Actually, what I'm going to do next is I'm going to do kind get kubeconfig internal, because we're actually inside of a container and for other reasons. I'm going to put that into .cube, just because. Actually, I'm going to put that into .cube config just to make my life easier. Now, by default, kubekettle will look for a file at /home.kubeconfig, and it will use that to authenticate to your cluster. So once that's there, I should be able to do get pods -a, and I can see all of the pods running inside of this single node Kubernetes cluster. And I can see that core DNS is started up, so my CNI is working, everything is working. And now we can actually go ahead and validate that broken state of this particular cluster. So I'm going to actually shrink this down a little bit so we can see that output a little better. Again, what I've done here is I've gone ahead and done kind create cluster --config kind config, and I pointed it at the local master build. And that will create a cluster of a single node set up in kubeproxy IPVS mode. And then let's go ahead and verify that that's the case. While that's happening, I'm going to go ahead and put that command down here. Kind create cluster config local master. And then after that, I pulled my kubeconfig. So that was kind get kubeconfig. Thank you. Good point. Okay, so ignore that first one. So I did my create cluster. You know what? I'm just going to do that again. There you go. So I did my create cluster against the local master check or the local master image, and then I went ahead and did a cube. I got the kube config for it, and I threw it into .kubeconfig. And now I'm able to actually interact with the thing. So I can actually do kubectl get pods. I can see all of the pods across the whole thing. -A, if you didn't know it, is actually a relatively new short thing. I used to have to type in --all namespaces. And now it's just -A, which is awesome. I keep meaning to tell Ben about that. See, he's still doing --all namespaces. Anyway. So let's verify our functionality here. So what I'm going to do is I'm going to do a kubectl get node -o-yaml pipe grep pos. And I'm doing that because I just want to grab the pos image to create my deployment. So I'm going to do kubectl create deploy test image equals paste. And what this is doing is it's going to create a deployment of the pos image just to give me something to surface, right? I'm not actually trying to show off functionality here. I'm trying to validate IPVS mode. So I'm just going to create a container. It's the pos container. It's running locally inside the cluster, makes it simple. Now I'm going to expose that, kubectl expose, deploy, test, port equals 80. We know that it's not listening on port 80, but bear with me. And so now I've created a deployment, and I've created a service that exposes that deployment. And now I'm going to jump into the container image and take a look around. So docker exec ti. Remember, all of these commands are in our slide deck. So if you want to follow along and you're not with me completely, you can go to kind.k8s.work. All of the commands are in a slide on that deck. Kind control plane IP adder show dev IPVS. Nope. Kube IPVS 0. How about that for memory? Boom. All right. Okay. So and that command is actually, I should have made a short command for that. That would have been smart of me, but you know how it is. Anyway, so that docker exec command is actually on the slide though. And you can see it. And basically what I'm trying to see in this output is the cluster IPs that are associated with the IPVS interface. And the neat thing about this is that the output tells me, 1, I have succeeded in running IPVS mode. 2, that I can see the cluster IPs that are associated with it. Have you ever wondered why you can actually suddenly ping service IP addresses if you're in IPVS mode? Because how many people know that you can't ping service IP addresses if you're not in IPVS mode? Cool. You can't because it's an IPVS, it's an IP tables trick. So by default, you can't ping a service IP. You can only ping a pod IP because really we didn't ever create IP tables rules to actually forward ICMP to those backend points. Kind of a fun fact. All right. So now what I'm going to do is I'm going to go ahead and delete that service. Kubectl delete svc test. And what I'm expecting to see, what I want to see, is that the IP address associated with that service becomes unbound from the IPVS interface, right? So let's take a look at that. If I still see this IP address associated with it, then I know that it didn't work, right? I'm going to up arrow and run that command again. And sure enough, I still see that that cluster IP working, even though it's not defined, right? The service that associated that IP address with that interface has been deleted. So that IP address should be released, but it hasn't been. That's the bug. So our fix is to remove the 19 lines of code that was keeping it around. So now what we're going to do is we're going to create a new cluster and show the change in functionality. How many of y'all are with me? Awesome. All right. I'm going to do kind delete cluster. Broken anyway. And then I'm going to go ahead and do my kind build cluster, or kind create cluster again. Only this time I'm going to use my new tag, which represents the new change, right? So I'm going to say kind create cluster --config, same config, because it still puts it in IPVS mode. The only difference in this command and the last one is that I'm going to point to that other tag, the fix tag. Then we're going to kick this up. Now, when you build, we'll talk about it here a little bit more in just a second, but when you build these things, there's a bunch of stuff that's left on the disk, and I'll talk to you about how to clean all that stuff up. So let's go ahead and fix our kubeconfig, just like we did before. No change in the command. But we need to update it because obviously all of the certificates from the old cluster are now gone because we deleted it, so we need to create a new one. So let's go ahead and create our deployment, just like we did before. And our service. I'm just up arrowing into my history here, so you should be able to do that part easily as well. Except that I think I went too far. There we go. And then I'm going to go ahead and delete. I'm going to go ahead and validate that the configuration is actually on the node. So let's take a look, and then we see again that there's another IP address associated with the IPVS interface. And if we delete that service, we see the IP address get released. All right, so this is the punchline. You can iterate over this stuff. You don't have to get it all right all the time. You can just continue to iterate until you get it right. You can get it working locally. You can feel good about it. You can feel confident in your change. And you can ship that change in a PR. We're at time? Okay. So the last thing I wanted to show you was the cleanup, right? So, and basically it's in our slides as well. So if we wanted to go ahead and Docker stop build-env, that will remove the image. And then if we do Docker images, we can see some of the stuff that's left behind. So there's some dangling volumes. That's what these things are. There's some dangling build images, and these things all take up a good amount of space, right? So if you want to clean that stuff up, the commands to clean it up are locally. For my part, I'm just going to do Docker system prune all volumes, and that removes everything. And that cleans up everything after behind it, and we can see how much data we used. We basically used 18 gig worth of space to do all of this testing. So I hope you all learned something. Thank you so much for your time. I know it was a lot of time, and there was a lot of quick pace stuff and lots of CLI stuff. Check out the slides. We're actually going to build a full-on tutorial on kind.sigs.k8s.io, much like some of the other tutorials that I built before. So you'll see that there after KubeCon is over and we've had a chance to breathe. Thank you, thank you, thank you.